Hello everyone, welcome to Kirti's Learning Factory. In today's video, we are going to learn something about E. What is E? E is the Euler's constant. See, in mathematics, there are a few phenomenal constants which are used all across maths. Pi, E, right? Then there is, what else is there? Yeah, there are a few other irrational numbers like root 2. So all of these numbers, they are used as constants, okay? But they are also irrational numbers. E is also an irrational number. You must have seen e raised to the power something, 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 and all of that. If you study physics and whatnot, and roughly the value of e is 2.71. That's not the value of e. The value of e runs up to infinity. And because it runs up to infinity in a non-recurring fashion, it's an irrational number. So today we are going to learn a few interesting things about Euler's constant. Okay. Euler was the physicist who calculated the value of this constant and called it E. Yeah. And I hope not behind his name. Anyway, so let's first understand conceptually that what exactly E stands for. So E is you can say that E is used to understand growth. Okay, so E is used to understand growth. So in calculus, you will always learn about graphs, and you will learn about the rate of change of the graph, right? Which is nothing but the angle that at any given point of time, the graph will make with the x-axis. This rate of change, this dy by dx, is equal to tan theta. So E, in a way, it speaks the language of growth or rate of change, and which is why it is often used across as a constant in math as well as physics. If you draw E's graph, this is x-axis, this is y-axis. The graph is, it runs like this. This graph is e raised to the power x. This point here is 1 because at x equal to 0, e raised to the power x is equal to e raised to the power 0. The value will be 1. So it cuts the y-axis at 1. It is the only graph. It has got a unique property. It has got a unique property. It is the only graph, or it is the only function for which the slope or the dy by dx, which is nothing but the differential, or the tan theta at a point, at any given point of time, is ex. If you calculate the area under the curve at the same point, all this area, that is also equal to e raised to the power x, and the function itself is e raised to the power x. So you see, the tangent at this point, if you take a tangent, that tan theta value, say this comes here and makes an angle theta, this tan theta value is also ex. If you take the graph, this goes up to negative infinity. Okay. If you take this graph, the area under curve at this point of time, which is basically the integral value, that is also e raised to the power x. And the function itself is also e raised to the power x. So isn't it unique? The differentiation, the integration, and the function at all given points of time is the same value. So that's interesting. And that really tells us that, therefore, E as a constant, it becomes the basis of growth in calculation, in maths, in physics, and in many other applied fields like that. Now let's take a step back and kind of construct that what makes how the value of E comes out to approximately 2.71. Okay, and because E is nothing but it is a basis of growth, let's learn it in this simple fashion. Say at the beginning of the year you had 100 rupees, okay, and if you were to double the money in 1 year, if you were to double the money in 1 year, which means you get 100% interest at the end of the year. How much money will you have at the end of the year? You will have 200 rupees. Correct? You will have 200 rupees. So what is the growth here? The growth here is 2 times, right? 1 becomes 2. Similarly, the same 100 rupees, say every 6 months, you get 50%. So will you make more or will you make less? Let's see for ourselves. We put 100 rupees at the end of first 6 months. We make 50. So we make 150. And then for the next 6 months, we make 50% of this 150, which is 75. So how much do we make at the end of it? We make 225. So what is our rate of growth now? It's 2.25. Now assume that if this were to be done every month, but again, this 100% rate of growth will also need to be broken, correct? Because here we broke it into half. Now we are growing this amount every single month, and the rate of interest is proportioned into 12 portions. This will lead to 100 into 1 plus correct. So very quickly I am going to make the calculation. I'm using a calculator right now, and yeah, so the rate of this basically comes out to be 261. So the rate of growth, as you can see, is now 2.61, correct? So if we started with 1 rupee, now, so what we are seeing now that the growth is becoming more and more real time. Yeah. What we are doing that instead of adding the growth or adding the increase right at the end of the period, here we added the increase, we divided the time period into 2 halves. And then we also proportioned the rate of increase accordingly. So if we are now increasing the sum every half of the time duration, then the rate of interest we have halved. Here, now we are increasing it every 12, every month. There are 12 months in the year. So the rate of increment is now 100 by 12. Similarly, imagine if we were to do it every single day, right? Every single day. So the rate of increase, will be 100 by 365, correct? Every day we are adding this percentage to the amount. And then we are increasing it till 1 year. So when we do this maths, which is let me see what is the value we get. I'm again going to use my calculator. So I'm gonna raise this to the power of 365, and it is 271.4567, which means that the rate of increase in this case comes out to be 2.71. Now we can break it down into further, in hours, etc. So the point being that the more real time your growth becomes, while you try to double your amount, okay, the idea is that we need to double it, correct? And that's where we started off, that we had 100 and we had to cover the journey of 100% addition to the initial amount, correct? So we reach from 100 to 200, which means that our rate of growth will be 2, correct? From 100 to 200, the rate of growth is equal to 2. है ना? The more real time the growth becomes, because here the growth is happening after 1 year, correct? The more real time our growth becomes, as you can see, the moment we started growing it every day at a proportioned rate of increment, we can already see that the rate of growth is 2.71. And that is what the concept of E is all about, that this makes the fundamental of growth, right? This is a constant, which is a growth constant, and which is why it is used massively in calculus. And that's why you will see that the tangent at every given point of time is the same as the area under the curve at that point in the graph. And that's the unique property that it has. So that was about E. If you liked it, then please go ahead and like my video and keep coming back for such interesting concepts.